Hello, ladies and gentlemen. If you have seen almost any tech announcement lately, you are probably already overwhelmed by the buzz around on-device AI. Terms like Apple Intelligence, personal intelligence, AI advancements from Google, Meta, and Microsoft are being thrown around constantly. All these companies boast about on-device AI. AI models running directly on your phone or PCs. From Apple's Neural Engine to Microsoft Recall and even Meta's AI, they all promise smarter, faster, and more private AI experiences. And this new wave of AI has brought another buzzword into the forefront, that is NPUs, Neural Processing Units. Suddenly, every tech company is talking about NPUs, the special chips inside your devices designed specifically to run all the exciting AI. But that leads to an important question. Are NPUs the real deal, or they are just the next piece of Silicon Valley hype? We have seen fads like NFTs, blockchains, and the metaverse rise and fall. So are NPUs the next big thing or just another tech gimmick? Well, after diving deep into research, I found the answer is a bit of both. Let's start with understanding of NPU. Here is a close-up of Apple's M3 Max chip, one of the most advanced laptop chips on the market. It is what's known as an SoC, system on a chip, meaning it combines multiple processors into one package. The next is CPU, that is Central Processing Unit, the main brain handling most tasks. The next one, GPU, Graphics Processing Unit, specialized in rendering graphics and running parallel tasks. Display engines and input-output, handling display output, USB ports, Thunderbolt, etc. NPUs, Neural Processing Unit, Apple's Neural Engine, the part designed to run AI models. But here is a surprising fact. For all the hype surrounding NPUs, they are actually taking up a tiny portion of the chip's die area. Even the display engines and I/O components take up 5x more space than the Neural Engine in Apple's M3 Max. Why so small? Interestingly, Apple uses the same size NPUs across its M3, M3 Pro, and M3 Max chips despite difference in overall chip size. That proportionally, the NPUs become more significantly in smaller devices like the iPhone's A17 Pro, where space is at a premium. And it's not just Apple. NPUs have been built into smartphones since 2017, but only now starting to appear in PCs. Why the delay? It all comes down to trade-offs. Listen to AMD CEO Lisa Su talking about NPUs. You guys are always pushing us to give you more. More tops, Lisa, more tops. She is referring to tops, that is, tera operations per second, a measure of how fast an NPU can run AI calculations. Companies like Microsoft are pushing chip makers to prioritize NPUs over adding more CPU cores or other features. But space and power are limited, so it's a balancing act. To really understand NPUs, we need to talk about accelerators. At its core, your computer is just a giant calculator. Everything, images, sounds, text, is ultimately just numbers that your computer processes. In the early days, all of this was handled by the CPU, a flexible general-purpose chip. But soon, engineers realized that some calculations didn't need to be that flexible. Example, rendering graphics for a 4K display means that updating about 500 million pixels per second, a simple calculation repeated millions of times. CPUs struggle with this load. GPUs, that is graphic processing units, were invented to handle these repeated tasks more efficiently. The same logic applies to NPUs. If we are going to run AI models, doing the same kind of calculations millions or billions of times, it makes sense to have a specialized chip to handle that. That's exactly what NPUs are. Accelerators designed specifically to run neural networks efficiently. Let's see how neural networks work. Let's break down how a simple neural network works. Imagine we have a super basic AI called MIM, that is Martin's image machine. Its only job to look at a 4-pixel image and tell if there is a diagonal line in it. Here is how it works. Each pixel is either a white or a black, we put those numbers into our neural network. The network has neurons, essentially small memory cells arranged into layers. Each connection between neurons has a weight, a number that influences how strong that connection is. The network multiplies the pixel value by its weight, adds the result together and makes a decision. If the pattern matches a diagonal line, the network output is 1. If not, it outputs 0. That's it. At its core, neural networks are just a series of multiply-accumulate calculations, multiplying two numbers, adding them up and repeating that process billions of times. Of course, real-world models are much more complex, billions of neurons and trillions of connections, trained on a massive dataset in remote server farms, then composed, comprised and shipped to our devices to run on NPUs. Now that we have understand the math, what makes an NPU different from a CPU or GPU? NPU is optimized for massive parallelism. Thousands of simple cores working together to perform billions of calculations simultaneously. High memory bandwidth. NPUs need to load entire AI models into memory, sometimes billions of parameters at once. That's why devices with more RAM can run bigger model. The next one, low precision calculations. AI doesn't need hyper accurate numbers, it just needs to guess good enough. Using lower precision math speeds up calculations and reduces memory usage. Power efficiency. NPUs are designed to run quietly in the background without draining your battery much. If you are thinking, is not that exactly what GPU does? You are not wrong. GPUs have been running AI workloads for years. NVIDIA's Tensor cores, found in GPUs since 2017, are specifically built for AI. A high-end RTX 4090 has 512 Tensor cores dedicated to AI, and in many cases, GPUs are still outperform NPUs in raw power. So why bother with NPUs? GPUs are power hungry, they are built for peak performance. NPUs are designed for power efficiency, handling small AI tasks without burning your battery. So what kind of tasks are NPUs actually good for? Tasks that run quietly in the background like crash detection on your phone, real-time voice dictation, blurring background during video calls, optical character recognition for apps like Microsoft Recall, which takes screenshots every few seconds and make them searchable. The idea is that NPUs can handle these jobs without waking up your CPU or GPU, saving power and running smoothly. Here is the next big question. Are NPUs actually the next big thing? Right now the answer is still unclear. Some use cases like Microsoft Recall make perfect sense, but a lot of the AI demos being shown like image generation or chatbots could easily run on a GPU instead. It all comes down to whether developers can come up with a killer application that really benefit from low power, always on NPUs. With all the AI hype going on, I have found myself craving more real creativity, not just prompting AI but actually creating things. Thanks for watching and I will see you in the next video.